I'm Matthew.
I'm Michelle.
I'm Minnie.
I'm Paige.
I'm Denise.
I'm Dan.
I'm Sarah.
And I'm Jessica. I'm Jessica. I'm a news anchor and broadcast meteorologist.
I'm Sarah. I teach high school math and science, and I also work for the FSU STEM Institute, where I team up with Jessica to teach students, just like you, about meteorology.
In our first topic, we will look at moon phases and different motions, like rotating versus revolving. Then we'll learn about weather fronts and do an experiment that demonstrates how warm air rises over cold air. We will look at thunderstorms and see why they can be so dangerous and uncertain.
We'll discuss hail and how it forms into dangerous projectiles that fall during thunderstorms. Finally, we will conclude today's episode by learning about one of weather's most interesting and perilous scenarios, tornadoes.
Stay tuned for Sci Notes Meteorology. Included in most weather reports is the moon phase. But why do we talk about moon phases on the weather report, and what are the moon phases?
A lot of people may think, how could a chunk of rock more than 200,000 miles away affect me? Well, the moon's gravity affects Earth, and it causes certain motions in our bodies of water and in our atmosphere. It changes the height of our tides. But it's not just the obvious things like boating and fishing that get affected by the moon. Farmers do too. Many farmers still plan their crops based on the phases of the moon.
Our moon doesn't shine, it reflects. Just like daytime here on Earth, sunlight illuminates the moon. We just can't always see it. So what are lunar phases?
During a new moon phase, you can't see the moon in the sky because the sunlight is hitting the moon's side that is facing away from us. When sunlight reflects on the near side, or the side of the moon that we can see from the Earth, we call it the full moon.
The sun, moon, and Earth are not in the same plane, and this is how we can see the sun and the sun's reflection on the moon. Depending on the moon's position, different fractions of the illuminated surface are visible. This gives us the moon cycle. This cycle takes about 29.5 days to move through different moon phases.
The phases of the moon in order are new moon, waxing crescent, first quarter, waxing gibbous, full moon, waning gibbous, third quarter, and waning crescent.
During waxing moon phases, the moon appears to grow larger. You can think of this as waxing a car. As you wax your car, the wax gets thicker and thicker. During waning moon phases, the moon appears to grow smaller. You can think of a whiny, crying baby. We want to spend less time with that crying baby. And so we're getting smaller and smaller amounts of visible moon.
Well, Jessica, that was a lot of information to take in at once. Maybe we should play a quick recap game of what is it?
All right, let's do it. What is it?
You're right, it's a new moon. You got it, waxing crescent. First quarter was the right answer.
Waxing gibbous, that's correct. This one's a full moon. Waning gibbous, you're right. Yep, that was the third quarter. And waning crescent, you're right.
Now that we know what the lunar phases are, let's talk about rotation versus revolution. When we talk about the moon, the Earth, or the sun, we can often refer to terms like rotating and revolving. The Earth is constantly revolving around the sun, but it's also rotating on its axis. Many times people will use these words interchangeably, but rotating and revolving are not the same. So what's the difference between them?
Revolving is when an object moves in a circle or circular orbit around a central axis. For instance, the Earth revolves around the sun.
Rotating is when an object moves or is caused to move in a circle around an axis or its center. The Earth rotates on its axis. We can imagine that the Earth is spinning on a stick. That's imaginary, of course. It looks like we're about to get some exciting weather.
I think we are. Fronts are boundaries between air masses that differ in both temperature and moisture content.
The four different types of fronts are cold, warm, stationary, and occluded.
Let's take a look at a weather map together and see how the different types of fronts affect the weather. The first type is a cold front that can be defined as cold air pushing into warm air. These fronts are the fastest moving fronts. The cold air is denser than the warm air, and as the cold front moves into the warmer air mass, that warm, less dense air rises up to produce clouds. Cold fronts are normally associated with thunderstorms and severe weather. They're represented by blue arrows on a weather map, and those arrows show the direction the front is moving.
The second type of front is a warm front. This happens whenever warm air pushes into colder air. This type of front can also bring stormy weather, but normally it's not as severe as cold fronts. Warm fronts are slower moving than cold fronts. When you see them on a weather map, they're represented by red semicircles. These semicircles face the direction that the air is moving.
The third is the stationary front. This forms when a front stops moving. If a warm and cold front are colliding, but neither is strong enough to take over, the front just sits there. Winds blow parallel instead of perpendicular, so the front doesn't move. This is typically associated with unsettled cloudy weather. It can be rainy and gloomy for days before the winds shift to move the front or it dissipates. This type of front is represented by alternating triangles and semicircles.
The last type of front that we're going to learn about today is an occluded front. An occluded front is created whenever the faster cold air catches up with the warm front and then it overtakes it. Occluded fronts are often found around areas of low pressure, but they can also occur when storms are fizzling out. Occluded fronts are shown on a weather map as purple with alternating triangles and semicircles on the same side of the line.
These are the 4 fronts you'll see displayed on a weather map. Understanding these fronts and how to recognize their symbol on these maps is important for meteorologists to demonstrate what's taking place in the atmosphere and communicate this to the public. As you can see, each front has its own set of characteristics and weather forecasts that come along with it.
Now that we've learned more about the weather fronts, let's do an experiment to show what will happen whenever the cold air and the warm air meet.
Okay, we're gonna do a very fun experiment, and Sarah, you can do this at home yourself as well. It's very easy. These are a lot of materials that you probably already have at your house. You'll need a glass bowl or a glass container, such as a casserole dish. You're gonna need some cups of water. You're going to need some oil and also some modeling clay. I actually took this for my little girl's art kit, so hopefully she won't be too mad. What you're gonna do is you're gonna create a barrier in this glass. And we need to make sure that it's a firm barrier because we don't want anything to escape. And then Sarah, you have the water, so tell them what you're gonna do with the water.
All right, so for our colder water, we're gonna represent that with blue food coloring. And we're just gonna do 2 because we wanna make sure that we have enough. We wanna make it as big as we possibly can.
Okay. Do you need
Yes.
this to stir?
Sure.
To make sure we have very blue water. Now remember, the water is going to represent the cold air. And I have oil in this measuring cup, and that is going to represent the warm air. I'm going to put a little bit of the red food coloring. It's not going to mix as well as the water because, of course, we're putting this in oil. Now, why do we use oil? You want to tell them, Sarah?
Well, whenever we did this experiment a few times, we would have sometimes it would work and sometimes it wouldn't. So Jessica and I made a decision to change it to oil and water so that we could also talk to you guys about density. And density of water is greater than the density of the oil. So we're going to have the 2 lay separate the way that we really need them to.
Yes, and so this is just like warm air. Warm air is less dense than cold air. So the oil is less dense than the water. Okay, Sarah, you want to pour yours in and I'll pour mine in. So there's the oil and there's the water. And I'm going to remove the barrier and look what happens. Okay, what happened was the oil went over top of the water, just like what happens with cold air and warm air. The cold air is going to be underneath, the warm air is going to be on top. That layer in the middle, what happens when you have red and blue together?
We're gonna get that purple, we're gonna get that front where they overtake each other.
Yes, just like an occluded front, where that cold air catches up with that warm air and overtakes it. Remember, warm air is less dense than cold air, so warm air is always going to rise.
Hi, my name is Brooke Richardson. I am a meteorologist for WJHG in Panama City. My favorite part about my job is that every day is different. You're not going to go in and do the same things. I mean, we do have those days where you have a sunny stretch of days, but every day is going to be different. Some days we're making forecasts. Some days we're going out to schools and talking to children. It's all just sort of different. It's all exciting. So for me, I actually think that it's really important for people to see what is going on outside, because if you know there's a tornado warning, all you see is that red box. But if you have somebody out there and they're showing you what's going on, I think that's really important for people to see what's coming at them, and they're more likely to take shelter. Every meteorologist actually sort of uses different data. We all sort of have our favorites. I use the GFS, the European model. That sort of gives us an outlook over several days of what the weather is going to look at. So what got me into the field of meteorology was actually when I was in high school. I helped clean up after some tornado damage for the outbreak in 2011 in Alabama. So after that, I just had a lot of questions about what tornadoes were, what formed tornadoes, just sort of like the scientific method. You start off with a question and you just sort of go for it. So that's what really got me interested in the field of meteorology, and that's what I decided to pursue when I went off to college. There is a lot of math and a lot of physics that goes into meteorology, so just keep up with your studies, keep pursuing it. It is a very rewarding field. You can do a lot of stuff with meteorology outside of TV, so I would just say just keep pushing forward. It is a really fun and rewarding job.
Thunderstorms produce rain, lightning, and of course thunder. Severe storms can have hail or produce tornadoes. Without moisture and some type of lift, you can't have a thunderstorm. It's like a recipe. You need to have all of those ingredients to make the thunderstorm.
In this meteorology segment, we're going to look at the structure of thunderstorms. We will establish that lightning must be present to have a thunderstorm, and we'll learn how to calculate how far away a storm is by measuring the time between seeing lightning and hearing thunder.
A thunderstorm occurs whenever we have rain and lightning. No lightning? Well, then that's just regular rain. You can also get hail, strong winds, and tornadoes during a thunderstorm. Thunderstorms typically last about 20 to 30 minutes, but sometimes they're a little longer. Remember, the key to being a thunderstorm is that lightning has to be present. So if it's raining and there's just one bolt, is it a thunderstorm?
It only takes one lightning bolt to be classified as a thunderstorm. The ideal situation for a thunderstorm to occur, or the perfect ingredient, would include the right moisture, instability, and a lifting mechanism.
In addition to these ingredients, thunderstorms also happen because of unstable air and lift. The cold and the warm fronts create that lift, and that's known as a frontal lift. There's also orographic lift, which happens whenever air rises over a mountain. When two air masses come together, like a sea breeze, we get convergence, which is another form of lift. Convective lift occurs when air gets heated by the sunlight, and then it rises.
With all of these lifting mechanisms, the upward motion of air leads to formation of clouds and precipitation if there's sufficient moisture to reach condensation as the air cools while moving up. How unstable the air is determines how explosive these thunderstorms can be.
Now that we better understand thunderstorms and know the necessary ingredients for one to occur, let's see how to determine how far away one is from where we are right now.
Okay, we're going to do some calculations. When you see lightning, begin counting until you hear thunder. For every 5 seconds you count, the storm is 1 mile away. So let's try it.
So if you counted to 20 seconds between seeing the lightning and hearing the thunder, then you divide that number by 5. You're going to get 4. That tells you that the storm is 4 miles away.
So next time you see and hear a thunderstorm, you can try this out for yourself, but make sure that you stay indoors and safe.
My name is Lieutenant Leanna Cox. I'm the Emergency Manager and Meteorologist for Naval Support Activity Panama City. When we're looking at weather as far as an operational force, some of the things that we need to look at are much more detailed. A marine forecast that you get on the local news is really for, the fishermen that might be going out, or somebody who just wants to go to the beach. When we look at forecasting, we look at how it impacts the mission, because our mission is so dynamic and so very changing. You can think a hurricane is going to do one thing, and then in 8 hours it turns, or it falls apart and it doesn't even make landfall. So it's kind of a great job because like we don't get so much flack for being wrong because we have to rely on nature. Our forecasts are based on data that's collected, but certain elements can change that forecast very fast. Our forecasts are much more focused on the first 24, 48 hours most of the time, and we update those forecasts about every 6 to 12 hours as we need to, because again, nature is very dynamic and she does what she likes to do, and our operations have to go on no matter what. So being ready to make those changes and get those reports out to the teams and the vessels and the aircraft that need them in a timely manner is very essential. Our objective really is to provide support from the seafloor all the way up to the stars. We don't know what's out there still. There's so much we need to learn, and as long as you're somebody who has an interest in, moving forward with science, our community goes in so many different directions. It's not just about doing a forecast. We have a lot of science that goes into, like I said, space studies. We have information that goes into seafloor studies. So there's so much to cover. Like, you don't have to be, oh, I want to forecast weather. There's so many areas that meteorology, oceanography covers. And there's probably a niche in there somewhere for you if you like a little bit of science and a little bit of math.
This may be the 100th time that we said it, but it's just like the classroom. If your teacher says something to you 100 times, it's important. There has to be lightning present for the storm to be called a thunderstorm. So what's lightning?
Lightning is a bright flash of electricity produced by a thunderstorm. These electric currents are very dangerous, and if you hear the sound of thunder, then you are in danger of being struck by lightning.
That's right. Between 75 to 100 people die every year from being struck by lightning. Lightning injures and kills more people than hurricanes or tornadoes.
Within clouds, many bits of ice or frozen raindrops bump into each other as they move around in the air. All of these bumps create electrical charges, and after a while, the cloud fills up with these electrical charges. The positive charges, or protons, form at the top of the cloud, and negative charges form at the bottom of the cloud. A positive charge builds up on the ground beneath the cloud. Since opposites attract, the positive charge coming up from the ground eventually connects with a negative charge coming down from the clouds, and then zap, a lightning strike.
While it takes lightning to be classified as a thunderstorm, just because you have lightning, does that mean it's a severe thunderstorm?
Not exactly, Sarah. When you hear meteorologists say there's a severe thunderstorm warning, that means the thunderstorm has other hazards, such as damaging winds, hail, or even a tornado.
Jessica, you mentioned warning. What's the difference between a watch and a warning?
That is such a good question. A thunderstorm watch means conditions are favorable for severe thunderstorms to possibly develop. A warning means that a severe thunderstorm is happening now.
So you're telling me that I need to watch out for thunderstorms, and if you're warning me that I should take cover right then, it's here already.
Exactly, that's a great way to remember it. Thunderstorms are severe if they have gusty winds, hail, and/or tornadoes. Frozen precipitation that falls from the sky is called hail, and hail comes in all shapes and sizes.
So how big and how little can I expect hail to be?
So it can come in a range of sizes, from the size of peas to softball size.
Oh my goodness, softballs are huge.
Yeah, it's pretty scary. So let's talk more about hail, why it forms, and what conditions affect the size of the hail.
We'll start by looking into the structure of a cloud. A cloud is made up of tiny ice particles. During a thunderstorm, downdrafts will force these crystals downward, where they're going to melt.
And an updraft will catch them and bring them back up to the top of the cloud, where they refreeze. When the currents of air within the storm shift or the hail becomes too heavy, it will fall out of the cloud.
Hail size grows larger the longer that the hail remains supported by the thunderstorm's updraft. So the stronger updrafts produce larger hail. Other factors can influence hail as well.
A supercell thunderstorm is a strong thunderstorm. It has something we call a mesocyclone, which is a rotating updraft. In a mesocyclone, you'll see winds change in direction and speed as you move vertically through the storm. This is what creates that rotation.
Florida is the thunderstorm capital of the United States, but the risk of large hail is minimal. This is because the temperature in Florida is way too warm most of the time for hail formation. It can happen, but it's not as common as locations like Nebraska, Colorado, and Wyoming. They're known as Hail Alley.
When hail forms, there must be a large vertical layer of freezing temperatures. Hail size is often described in relation to other items that people can see visually. You will hear a meteorologist refer to pea-size hail all the way up to softball-size hail. Softball-size hail is about 4.5 inches in diameter.
Here's an experiment that you can do at home to simulate crystals being suspended in the air by an updraft. In our experiment, the hail will fall from the updraft as it shifts, but the hail can also fall to earth whenever hail becomes too heavy to be supported by the updraft. These are materials you may have at home. The only thing that you'll need are ping pong balls, a ball with a little bit more mass, and a hairdryer. So we'll start by pointing our hairdryer upward and turning it on. Then we put the ping pong balls in the stream of air, and the ping pong balls will remain suspended until the air is tilted. When the hairdryer is tilted, the balls are going to fall out.
So this shows how the updraft of a thunderstorm supports the hail and allows it to recrystallize and grow until the updraft tilts. So once hail grows and gets too heavy to remain suspended by the updraft, it will also fall to the ground. So again, when we turn this on low, there's your updraft, the updraft can tilt, and then the hail falls out. But what if we had a larger ball representing larger hail? So I'm gonna let you hold this, Sarah. I'm gonna turn it on again, and what happens? It falls right out. So when the hail grows to a large enough size that the updraft is too weak to support it, it can fall to the ground as well.
Annually, there are more than 1,000 tornadoes reported nationwide. These tornadoes vary in speed, path, and size, but the most violent ones can have speeds up to 300 miles per hour and can damage a path of up to 50 miles long.
Tornadoes form from thunderstorms when two different air masses collide, warm, moist air and cold, dry air. A change in wind direction and an increase in wind speed with increasing height creates a horizontal spinning effect, and then rising air within the updraft tilts the rotating air from horizontal to vertical, creating the tornado funnel.
A tornado is not officially called a tornado until it reaches the ground. Before that, we just call it a funnel cloud.
Tornadoes cause damage due to the excess amount of wind that's created. Damage ranges from minor roof damage from branches falling down on it to incredible winds that can pick up and blow homes completely away. The strength of a tornado is rated by the Enhanced Fujita Scale of Tornado Intensity.
The Fujita scale rates tornadoes from an EF0 to an EF5, with 0 being the weakest tornado and with 5 being the most violent. At EF0, you're going to see wind speeds from around 65 to 85 miles per hour, and you can expect some light damage, like tree branches falling and the roof shingles maybe being blown off. For an EF1, the speeds will range from an 86 to 110 miles per hour, and there's moderate damage. A portion of the roof could be blown off at these speeds. An EF2 wind speed ranges from 111 to 135 miles per hour. And there's considerable damage and potentially trees being uprooted.
Beyond EF2 is where tornadoes begin to really get scary. At EF3, the speeds are at 136 to 165 miles per hour, and there is severe damage. Trains can be overturned and cars can be lifted off the ground. EF4 speeds are at 166 to 200 miles per hour, which is devastating damage, and most houses are being leveled and cars are being thrown hundreds of yards at this point. During an EF5, wind speeds are over 200 miles per hour, and there's immeasurable damage with strongly built homes being completely blown away and cars being sent in the air and turning into dangerous projectiles. Sarah, do you remember the difference between a watch and a warning that we talked about earlier?
I sure do, and it's very important for our viewers to remember it too, so pay attention. A tornado watch is issued by the Storm Prediction Center whenever conditions are favorable for a tornado to develop. A warning is issued by your local National Weather Service office and indicates that a tornado has been spotted by a trained spotter or is indicated on a radar. So there is already one near you, and you should be ready for it. If there's a tornado watch or a warning in your area, please stay inside. and look for the safe areas in your home that you can hide in.
The lowest level of your home offers the best protection. You'll want to be in an interior room or hallway away from windows. Remember to crouch down on your knees and protect your head and your neck with your arms.
So I want to make sure that I do something like this as I go down.
Exactly.
Okay, we got it. I want to be able to plan my day so that I can take a picnic or go out on the boat or something, but that kind of needs to be planned.
And as a meteorologist, I like to be able to provide those answers to you, Sarah.
Thanks.
Meteorology impacts our everyday life, from our safety to knowing what clothes to wear. And now that you know more about the science behind the weather, you can be weather aware and educate others around you.
I'm Sarah.
And I'm Jessica. Thanks for tuning in to Sci Notes Meteorology.
Jessica's here.
Yeah. So, yeah. Remember to crouch. I'm sorry. Okay.
Florida is the capital of the United States.
No.